Hello my dear friends, welcome to the subject of statistics for the class 12th English medium part 1 chapter 3 the linear regression by Vitan sir. Today we will be discussing about the shortcut method of solving the least square formulas. The shortcut method for computing the regression coefficient. Now, if you remember the correlation coefficient, the shortcut method was the UV method. Remember that thing, the UV method. But then also we also have to remember one of the properties of the correlation coefficient, that it was independent from the change of origin and change of scale. Let me remind you guys once again, the change of origin means adding or subtracting values from the observation. The change of scale means multiplying or dividing values from the observation. So our correlation coefficient was independent from the change of origin and change of scale. Now in our current chapter, the regression coefficient is independent of the change of origin. That means we can add and subtract any value from the observation, our answer will not change. But regression coefficient is not independent from the change of scale. That means if we multiply or divide our regression coefficient observations, that is to find u and v, if we multiply and divide our values, our answer will change. Once again I am telling you guys, regression coefficient b is not independent from the change of scale. That means that if we multiply or divide it with any value, we will not get the exact original answer. So what to do about it? Now if we are not multiplying or dividing, that is we are just subtracting, that is we are subtracting a from x, that way we will get u, and we are subtracting b from y, that way we will get v, then we don't have to worry about anything, our answer will be same, that is our byx will be is equal to bvu. Here bvu means using the regression coefficient not for yx but uv. So whenever we are going to use uv, we will call it bvu, and whenever it is xy, we will call it byx. And right now when it is just addition and subtraction, the byx is equal to bvu. As you can see the formula here, it is very similar to the xy and x bar y bar formula we have used. N summation uv minus summation u summation v divided by n summation u square minus summation u the whole square. Now right now we are not multiplying or dividing it with anything, but what if we do? If u is considered as x minus a upon cx, cx is the value with which we are dividing the x variable, and v is equal to y minus b upon cy, where cy is the value with which we are dividing the y variable. Now when this kind of situation arises, what we do is this: b is equal to byx is equal to BVU. Now here BVU is the formula above the whole n summation uv minus summation u summation v upon n summation u square minus summation u square. The whole formula is BVU into cy upon cx. So to get byx using the uv formula, we will need to do this: bvu into cy upon cx, that is the whole uv formula, and then we will add one multiplication and division, that is cy upon cx. cy is the value which we divided with y, and cx is the value with which we divided the x. So remember this thing, whenever we are using the regression coefficient, we have to multiply with cy and divide with cx in the shortcut formula. Remember this thing, we are going to practice some sums of this method, so no worries, we will understand it better that time. Starting with illustration 4, to determine the relationship between monthly income and monthly expenditure. Here monthly income is x and monthly expenditure is y. So we have to determine the relationship. We have to obtain the regression line of monthly expenditure, and we have to estimate the monthly expenditure when monthly income is 75,000 rupees. So for this, first we will calculate the x bar y bar, because without calculating x bar and y bar we can't move forward. The x bar is 65.86, y bar is 55.29. the fractional values are there, so we can't use x bar y bar method, and the question values observations are big, so we are not going to use xy method. The method which we are going to use is the uv method, where u will be x minus 65. 65 is just an estimated assumed value because it is quite near to average. You can estimate 60, you can estimate 70. The final answer will be same if you haven't made any mistakes there. V is y minus 55. Once again a value which is near to average. Start by writing down the original observations, that is x observations, total, y, all the observations, and total. Now once you are done with writing down the question, start with the columns. We know that for uv method we need u, v, uv, u square, not v square. We don't need v square because we don't take the y variable in division, and because we are not taking a y variable in the division, we don't need the v variable here in the division, that is we don't need the v square column. In correlation coefficient we make all the columns, but in regression coefficient we need one column less, that is it might be y square, it might be y minus y bar whole square, or it might be v square. We don't need these columns. We will start with the u column. U is x minus 65, so from all the observations of x we will deduct 65 and we will make a total afterwards. V column is y minus 55, that means from all the observations of y I will be deducting 55. That way I will get the whole V column. Next is UV, that is the multiplication of U and V. And once you get this U into V, start with the U square, that is the square of the U column, which you are getting it like this here. Once you are done with all these 4 columns, make the total of each and every column. We will be requiring all these 4 totals in our sum. Now start by calculating the B. Here B is byx, that is bvu. Here we have only deducted the values, there is no multiplication or division, so we don't need cy upon cx in this question. Just the formula n summation uv minus summation u summation v divide by n summation u square minus summation u the whole square. Once you are done by the formula, write down the information in it. N is 7, summation u is 69, u is 6, v is 2. Divide by n is 7, u square is 118, and summation u the whole square is 6 square. Once you multiply and square the necessary values, you will get something like this. Then deduct the values and then you will get the answer as b is equal to 0.60. Now put this answer into our A formula, that is y bar minus b x bar. We already know this. The y bar is 55.29, b is 0.60, and x bar is 65.86. Solving this, you get 55.29 minus 39.516. That way you will get your answer for A as 15.77. Now you have got your B as 0.6, A is 15.77. Put both of them into the regression line of y on x, which would be y cap is equal to A plus bx. Putting the values, y cap is equal to 15.77 plus 0.6x. Now we have to take x is equal to 75, that was the monthly income 75,000 rupees. So we will put the value of x as 75 into our y cap equation like this, and that way we will get the answer 60.77, that is y cap is equal to 60.77 thousand rupees. If you have to write a statement, if the person has monthly income of 75,000 rupees, his approximate, that is the estimate of monthly expenditure will be 60.77 thousand rupees. Now that was an easy sum. Let us take another illustration, illustration 5. Here we have life of cars and annual maintenance cost. Now we know that these are a bit small values, but the thing is that if you check the x, each and every value is divisible by 2. 2, 4, 6, 8, everything can be divided by 2. And if you check the y, 10, 20, 25, 30, can you find something which with which we can divide each and every value? Yes, 5. We can divide 10, 20, 25 and 30 with 5. So what we are going to do? We are going to use the UV method, in which we will be dividing x with 2 and we will be dividing y with 5. It would be something like this, that x bar is 5, y bar is 21.25. We will take a as 4. You can take a as anything you want, I don't have any problem in that, but we are going to divide our x with 2. That means you can't take an odd number for x, for a. If you take an odd number, your answer will be odd, and when you divide it with 2, your answer will be in points. So we are not taking a as 5, we are taking a as 4. So that way our answer will be even, with which we can divide 2. You can take 2, you can take 4, you can take 6, you can take 8 as a. Now b can be taken as again anything, but right now we are going to divide y with 5. When we are going to divide y with 5, we can't take b as something which will not give us an appropriate answer. So we are taking b as 20. You can take b in the multiple of 5s. You can take b as 10, 15, 20, 25, 30, whatever you want. Right now we have taken 20. The cx, that is the divisible value for x, is 2, and for y it is 5. So it will be something like this, that u will be x minus 4 upon 2. Deduct all the x values with 4 and divide it with 2. V will be y minus 20 upon 5, that is deduct everything by 20 and divide it by 5. Now write down the question properly, write down the observations and make their totals. And once you are done with this, write down the columns, that is u, v, uv and u square. Here u is x minus 4 upon 2, v is y minus 20 upon 5. Be very careful while making the column. First of all is x, that is u column. The 2 minus 4 upon 2 is negative 1, 4 minus 4 upon 2 is 0, 6 minus 4 upon 2 is 1, 8 minus 4 upon 2 is 2. And then next is v column, that is y minus 20 upon 5. So 10 minus 20 upon 5 is negative 2, then 0, then 1 and then 2. So everything is in a sequence. Once you get this, multiply this to negative 1, negative 2 is 2, 0, 0, 0, 1, 1, 1, 2, 2, 4, and then make a square. Now once you are done with this, make the horizontal total, and that way your table is complete. Now start with your formula. Now as we know, we have divided our observations, so we have to make a small adjustment into our formula, that b will be not just bvu, b will be bvu into cy upon cx. Our formula will be bvu into cy upon cx. Now bvu is the whole n summation uv formula, and then multiply it with the cy upon cx. Once you have written down the formula, write down the values. Now n is 4, so 4 into 7 minus 2 into 1 upon 4 into 6 minus 2 square, into the cy, the value with which we divided y is 5, divide by cx, value with which we divided x is 2, so 5 upon 2. Now first we will solve the first bvu thing, which we have already done here, and subtract it, and once we are done with that, multiply all of them. So 26 upon 20 into 5 upon 2, the answer will be 3.25. Now once again I will tell you guys that write down the whole n summation uv formula and multiply it with cy upon cx. So that would be your twist in the formula whenever there is a division in your values. Now moving forward to formula for a, which is y bar minus b x bar, that is 21.25 minus 3.25 into 5. which is 21.25 minus 16.25, that is 5. So right now your answer for A is 5. Now the regression line of y on x is y cap is equal to a plus bx, and when you put the value into equation, y cap will be 5 plus 3.25x. In case you forgot, we don't have, in the last illustration we didn't have to find anything new, we just had to make a regression line, and because we just had to make a regression line, that was the end of the sum. We don't have to estimate anything, we don't have to find any error, etc. Now in this illustration, in the illustration 6, we have something extra. There is a sample of 7 students, their IQ and their marks are given. We have to obtain an through the examination of 75 marks is given. Their IQs are as follows as x and their marks are as y. Now first we have to obtain regression line of y on x. That's the first priority. Then we have to estimate the marks of a student whose IQ is 120. So that's the second question, that we have to put the value of x as 120 into the equation and then estimate the value of y. Now the third question, we have to find the error when IQ is 100. So the third question is, we have to estimate IQ as 100 and then find its marks and then compare. Right now for 100 IQ our marks are 50, as you can see from the question. For 100 IQ the marks are 50. So then we have to estimate from our regression line for 100 IQ what is the marks and then find the difference. So 3 questions are there: regression line, estimate for 120 and find error for 100. We will start by naturally writing down the averages. Here the x bar is 96.43 and y bar is 51.57. Both are fractions, no x bar y bar method, the values are big. No xy method, we have to use the UV method. Looking at the question, you can see that x is completely divisible by 5. All the values are divisible by 5. So for estimation of u, I have divided it by 5. For v, it could have been divisible by 5 if not for the 46 marks in the very first observation. So we are not going to divide it, we are just going to write it as 1. So no division for v and divided by 5 for u. Again I have taken the x as 95, which is divisible by 5, because without that we will not be able to divide it by 5. And for v I have deducted y with 50, which is a round figure value for the average. We will start by writing down the question itself properly. Don't make a mistake while copying down the question and the total. Now the columns are u, v, u, v, u square. Here u is x minus 95 upon 5, v is y minus 50, simple, no division. Now u is x minus 95 upon 5, so deduct 95 and divide with 5 for each and every observation of x. Then for each and every observation of y, just deduct 50. And once you are done with that, multiply both the columns and then make a square of the u column. These are the standard procedures we have been following since the correlation chapter, nothing new in that. Make a total. Once you are done with your table, move forward with the sum. Starting with b, now as there is a division in the x, that is in the u, we have a cx, so we have to follow this formula only. N summation uv minus summation u summation v divide by n summation u square minus summation u the whole square into cy upon cx, putting the values in this equation. Cy was divided with nothing, so we will keep it as 1. Cx, that is x, was divided with 5, so we will take cx as 5. Rest of the totals we have put into our equation. Multiply, square, subtract, and that way you will get your answer as b is equal to 0.56. So b is 0.56. Now formula for a is y bar minus bx bar, therefore 51.57, that is the y bar, minus 0.56, that is b. into 96.43, that is x bar. Moving on with our regular steps, we will get the answer of A is negative 2.43. Now we will put the values of A and the B into our regression line of y on x, that is y cap is equal to A plus bx. The values will be negative 2.43 plus 0.56 x. Now this sum is going to be continued. This is the first answer. The second is putting x is equal to 120. We have to estimate the value of marks when the IQ is 120. So we will put x as 120. We will multiply it with 0.56, which will give us 67.2. And when we add and subtract, we will get 64.77 marks. So when the IQ is 120, the marks are 67.1. 65 approximate, round figure answer is 65. Moving on to obtain the error. Now when IQ is 100, we have to obtain the error, but for obtaining error we need to find the estimate of y, that is y cap. So we need to calculate y cap when x is taken as 100. So y cap will be negative 2.43 plus 0.56 into 100, that would be negative 2.43 plus 56, which will give us a y cap of 53.57 marks. Now to find the error, we need to make a difference of the actual data and the estimated data. The actual data is 50, which I told you guys very earlier, and the estimate is the 53.57. So to find the error, our formula is E is equal to y minus y cap. Putting the observed data and estimated data there, we get the error as negative 3.57 marks. So my dear friends, this is called the error of estimation, that is negative 3.57 marks. Now, we are going to discuss this U and V method, but before that, we also have to understand about the regression coefficient from covariance and correlation coefficient. Now regression and correlation are related. As you can see from the formula, or as you can see from the definition or the concept of two correlated variables, we can say with surety then correlation coefficient and regression coefficients are connected. Even the covariance, the COV value is present in both of these formulas. So now let us understand how can we find regression coefficient from the given values of either a covariance, that is COV or the correlation coefficient, that is R. Now if x bar, y bar, sx square, sy square or COV are given, when this kind of values are directly given, what we are going to do? We are going to calculate the value of B as this: variance of xy upon variance of x, that is the COV upon sx square. As you can see, we have ignored the y variable sy and we have made a square of the single available variable. Now sometimes where COV is not directly given, we have to think about this formulas here. COV formula is either summation x minus x bar y minus y bar upon n, or summation xy minus n x bar y bar upon n. Both of these formulas are exclusive COV xy formulas. Also sx square formulas are like this. Now we have studied all these things into 11th, but we are just revising it here. Summation x minus x bar whole square upon n, no roots because this is variance and not standard deviation. Or summation x square upon n minus summation x upon n the whole square, this is something like the x bar. Or summation x square upon n minus x bar square, that's what I just said. Also if we have to find sy square, it is not actually necessary but sometimes we have to, then we have to just replace x with y into all the formulas. The second, when measures like x bar, y bar are, that is the correlation coefficient, sx and sy are given, what we are going to do is r into sd of y upon sd of x, that is r into sy upon sx. Remember this, r into sy upon sx, and a is as usual the Formula of A does not change. A never changes. A remains as it is. Only the formulas of B changes because B has options. A does not. A directly uses whatever formula B used and put it into the equation. We will start with practice equation here. Illustration 8 is there where the measures are obtained to study the relation between rainfall and yield of bajri in quintal per hectare in 10 different regions. Now n is 10, x bar is 40, y bar is 175, sx is 12, covariance is given as 360. We have to obtain the regression line of yield on rainfall. Now because we have to obtain the regression line, we always start with B, that is covariance xy upon sx square. The latest formula, putting the values into equation, we will get B directly as 2.5. Short and simple, right? Put this value into our A formula. Y bar is 175 given, x bar is 40 given, B is 2.5 which we have found, and you will get your answer as A 75. Put A 75 and B 2.5 into our equation, that is regression line of y on x, y cap is equal to A plus bx. That's your answer. Illustration 9. To study the relation between two variables, yearly income of a family and their yearly investment in mutual funds is given. X is the annual income in lakh rupees, Y is the annual investment in 1000 rupees. X bar is 5.5, Y bar is 40.5, XX 1.2, SY 12.8, R is 0.65. Now in this equation R is given. Now we have to estimate the annual investment when the annual income is 4.5 lakh rupees. Ignore the lakh rupees, take the value 4.5 at the last of our answer. We will start with our formula, that is B is equal to R into SY upon SX. The R is correlation coefficient. The formula is R into SY upon SX, and as we know, we will put the values into our equation and we will get the answer as B is equal to 6.93. Now put this value into our formula for A, that is Y bar minus B X bar. Y bar here is 40.5 and X bar here is 5.5 and B is 6.93. When we put all these three values into our equation, we will get something like this, that is 40.5 minus 38.115. The answer for A is 2.385, that is 2.39. So the round figure answer for A is 2.39, B is 6.93, and when we put both of them into the regression line of y on x, we get y cap is equal to A plus bx, putting the values 2.39 plus 6.93x. This is the regression line of y on x, that is regression line of annual investment over annual income. But we have to estimate the investment when the income is 4.5 lakhs, that is 4.5. So we will put 4.5 in the place of x and we will get the answer 33.575. If we write a statement here, y cap is 33.58. So when the annual income is 4.5 lakh rupees, the annual investment of the family will be 33.58 thousand rupees. This is how you do this sum. Moving on to illustration 10, the information of price of a ball pen and the supply of ball pen at the end of each month of a year for a company making ball pen is given. Now we have to estimate the supply of ball pen when its price is rupees 40. Price is X, supply is Y, average means X bar and Y bar. So X average X bar is 30, Y average Y bar is 500. Variance are S squares. For X it is SX square and for Y it is SY square, and R is 0.8. So in short, it looks like this. Now X bar is 30, Y bar is 500, SX square is 25, so normal SX will be 5, SY square is 10,000, so normal SY will be 100, just a square root it is, and R is 0.8. We have been given R, so the formula for B will be R into SY upon SX, which would become 0.8 into 100 upon 5. which will get us B as 16. Now put this into the equation of A, where y bar is 500, x bar is 30, B is 16, and that way you will get the answer A as 20. B is 16, A is 20. Putting these things into the regression line of y on x, y cap A plus bx, putting the value y cap is equal to 20 plus 16x. When we put x is equal to 40 here, we get y cap is equal to 20 plus 16 into 40, and solving this we get 20 in plus 640, that is 660 units. So that is when the price is assumed at rupees 40, the supply of units will be 660 units. So that's what statement we are going to write here. Moving on to the next illustration, illustration 11. uh, Person in a South India produces spoons from eatable materials and it can be eaten after using it. Okay, strange. We need this technology. He launched some spoons for the purpose of selling, and then he did some statistical analysis and he got that average price and the demand in 100 units for 6 months, and the data is given as N6, summation x 45, summation y 122, x square 439, xy 605. As you can see, we are going to mix up a formula to solve this sum. The regression line of demand of spoon and the price estimates the demand of spoon when the price of spoon is 10. Now as you can see here, summation x summation y was available, so I just found the x bar y bar, because without using x bar y bar we can't move forward with our sum. Now once we have got x bar as summation x upon n and y bar as summation y upon n, the x bar is 7.5 and y bar is 20.33. Right now the formula for B which you are going to use is pretty simple. N summation xy minus summation x summation y upon n summation x square minus summation x the whole square. The direct formula was available already. We just need x bar y bar, that's why I modified them. Now when you put the values, it is simple. You have already done this almost what, 20 to 30 times? Yes, most probably. So once you are done with this, you will get B in negative 3.05, and when you put this into our equation of A, as you know the y bar was 20.33 and x bar was 7.5. Now B is negative and our equation also has a negative, so negative negative becomes positive, and when you add the two values, your answer for A will be 43.21. Now put A and B into our regression line of y on x, which is y cap is equal to A plus bx. Putting the values, negative answer will be there because B is negative, so 43.21 minus 3.05x. Now in the question it was said that we have to put x as 10. So what if he keeps price at 10? What will be the estimate of the units demanded? Of course he is starting a new business, so he needs the estimate. Right now when you put the x as 10, you will get the answer as 12.71. So when he keeps price is 10 rupees per unit, his demand is 12.71 units. So the statement is when the price is 10, estimated demand is 12.71 units. Okay, pretty eatable. Moving towards the last sum of today's tutorial and the last sum before the exercise 3.2. The electricity generated by windmill, that's the subject of analysis today. The velocity of wind is x and electricity generation is y. Now who says that commerce people can't study science? You see, the velocity of wind, the electricity generation is a topic of science, but we are solving it, Tell those science people, yes, we are solving this sum in commerce. So the x bar is 20, the y bar is 186, the summation xy is 23,200 and sx square is 50. Right now looking at this equation, I am thinking that we might have to use that covariance xy formula, where we had to write summation xy minus n x bar y bar divided by n into sx square. I am thinking that that is the formula which we are going to use right now. You know, this way you have to remember each and every formula, else you are never going to complete this chapter on your own. Also, we have to estimate the velocity, we have to estimate the electricity generation when velocity is 25 kilometers per hour. Now, just I am rewriting the data in simple format, nothing new. Taking the value of B as covariance xy upon sx square. As I am writing here covariance, I am going to write the modified formula of covariance, that is summation xy minus n x bar y bar upon n. Sx square was already there, remaining is the expansion of the covariance formula. Now we have all the values here, so we will put them into equation, solve them, and that way we will get B as 18.4. Once we are done with the B, put this value into A. Solve the equation and you will get A as negative 182. The B is 18.4, is negative 182. So the regression line of y on x is y cap is equal to a plus bx, where y cap, putting the values negative 182 plus 18.4x. We are supposed to put the velocity of wind as 25 kilometers per hour, that is 25. So when we take x as 25, we get something like this, negative 182 plus 460. The estimated electricity generation is the 278 watts when velocity of wind is 25 kilometers per hour. A science sum solved by the commerce people. Hooray! So with this, I end my tutorial here. In the next tutorial, I am going to teach you with solution the exercise 3.2 of the linear regression chapter. I believe this chapter is going pretty smoothly. This chapter might seem a bit different than the correlation coefficient. Correlation was just finding the strength of a relationship between the two variables, while regression uses that strength of the variable, the strength between two variables, to estimate variable y from the given value of variable x. So correlation was just deciding whether we can estimate or not. If their strength is weak, the strength between two variables is weak, the regression doesn't give good answers. You can see that if correlation coefficient is a perfect positive or perfect negative, there are no errors in regression. If correlation coefficient is a partial correlation, then we find many errors in regression also. So correlation determines whether we can compare them or not, and if it gives us a correct yes answer, then we can move forward with the regression. So this is the kind of a practical use for this kind of sums. Now with this I end my tutorial today. My dear friends, see you soon next time with the solution of exercise 3.2. Stay home, stay safe, and stay studious.